In this lesson, we are going to start looking at quadratic functions. So we'll just review a few things before we get started. So a parabola is the shape of a quadratic function. So remember, quadratic functions are always x to the power 2. So we can express the quadratic formula or function in standard form, which is ax squared plus bx plus c. We could also express it in vertex form, which is a times x minus h plus k, where hk is the vertex. Or we could express it in factored form, such as a x minus r1, x minus r2, where r1 and r2 are the x-intercepts. So we'll look at all these ways, and they give us different information. So if we want to know the vertex, we have to put it in vertex form. So if a parabola opens up, it's called concave up, where the leading coefficient is positive, we would have a minimum value. And if the parabola opens down or concave down, where we have a negative leading coefficient, the parabola has a maximum value. So you would have done all this in grade 10, should all be reviewed, should look familiar to you. So when the equation is written in vertex form, we can then determine the maximum or minimum value. So for example, I have this parabola in vertex form, y equals 2 times x minus 1 squared plus 5. It has a vertex of 1, 5. Remember that it's x minus h plus k, so h is the value of the x-coordinate, not minus 1, it would be positive 1. And so it has a positive leading coefficient, means it's going to open up. The vertex is located at 1, 5, so it has a minimum value at x equals 1. So how do we change from standard form? So standard form is ax squared plus bx plus c, and we want to put it in vertex form. So that is ax minus h squared plus k. So sometimes we want to determine the vertex, and we don't have it in vertex form, we have it in standard form. So here we have a function in standard form, and we want to change it to vertex form. This process is called completing the square, because you will see that there is a square in this vertex form. This is a square. X minus h squared means x minus h times x minus h. It is a square. So we want to, that's why it's called completing the square. So what we do, if I had x squared minus 6x, and I wanted to factor that so that I get two factors that are exactly the same, then they would both have to be 3, because negative 3 plus negative 3 is negative 6. So basically I'm taking the negative 6 and dividing it by 2 to figure out what that needs to be, because x minus h squared is what we call a perfect square, meaning both factors are the same. So if I want both factors to be the same and 6x is the middle, then both of those factors would have to be 3 so that they are the same. So all I have to do is take the middle and divide by 2, and I get the value for 3. But keep in mind that negative 3 times negative 3 equals positive 9. So in order to make that a perfect square, that last number would have to be 9, but it's not, it's 13. So what we do is we say, okay, well, I'm going to add 9 to make a perfect square, because that's what I want, so that when I factor that, I get x minus 3 times x minus 3. But I can't just add 9, because then I've changed the equation. So whatever I add, I'm going to subtract. So I'm adding 9 to complete that square, right? So I'm completing the square, making it a perfect square so that it factors to 2 x minus 3's. But I can't just add 9. I also have to subtract 9, because that equals 0. So I haven't really changed the equation. So now I can write it as x minus 3 all squared. and then negative 9 plus 13 is 4. So now it's in vertex form. So the vertex is 3, 4. And just to show you that I haven't changed the equation, if I expand and put it back to standard form, I've got, oops, that's a negative. I've got x minus 3 twice plus 4. Well, x minus 3 squared is x minus 3 minus 6x plus 9. And that gives me back to the original equation. So I haven't changed the equation, I've just written it in a different way. So x squared minus 6x plus 13 can be written as y equals x minus 3 squared plus 4 in vertex form. Okay, so let's try another example. So 8x does not have a perfect square. If it was 8x, then it would have to be x plus 4 times x plus 4. So what I'm going to do is take the middle, divide it by 2 to determine what goes in that last bracket, and then remember I have to square that, so that makes it 16. So 16 would make a perfect square. Let's do it in a different color. So 16 would make it a perfect square, because when I factor, I would get 2x plus 4s. So I can write it as a square. So half of 8 is 4, square it, and it's 16. Whatever you add, you have to subtract. And then we had a minus 1 already there. So now I can write x plus 4 squared, because I have 2 of them. And then I'll just add the minus 16 minus 1 is minus 17. So the vertex is negative 4, negative 17. Okay, if there is a coefficient, we have an extra step. So what we're going to do is factor out that coefficient from first 2 terms only. So we'll factor out the coefficient from the first 2 terms. We're going to ignore that last term for now. So we get y equals 2 x squared minus 6x plus 3. Now we're going to complete the square as we did previously. So half of 6 is 9, half of 6 is 3, squared is 9. So I'm going to add 9 and then subtract 9. I'm going to put square brackets around that, and then I've still got this 3 on the end. And the reason I put square brackets is to remind myself, since I factored out 2, I have to multiply it back. So I get x minus 3 times x minus 3 from that square. 2 times negative 9 is negative 18, and then add 3. So whatever you factor out, you have to multiply back. That's the extra step when you have a leading coefficient. So negative 18 plus 3 is negative 15. So if there is a coefficient, you have to do 2 extra steps. Factor out the coefficient from the first 2 terms, and then multiply it back before you collect like terms. You may also have leading coefficients that are fractions. That's okay. I'm going to factor out a half from the first 2 terms only. Not the last term, we'll ignore that for now. So a half of 4 is 8. And then I'm going to complete the square. So half of 8 is 4, squared is 16. And then I'm going to add minus 16 so I don't change the equation. So I'm going to get my x plus 4 twice, which is what I want. I'm going to multiply this half by the minus 16. So it's minus 8. And then I'm going to write this out squared because I have 2 of them, and then minus 13. So there's my vertex. Okay, now we'll look at some applications. So no different, it's just going to be modeling a situation. So in this one, Jason is jumping off a cliff. His height is given by the function negative 16t squared plus 16 plus 180. And we want to determine his maximum height. So whenever I see the word maximum or minimum in the question, I know I have to put it in vertex form. So I'm going to complete the square. So the first thing that we would do, we do have a coefficient, so let's factor it out. So we want to take negative 16 out of the first two terms. I don't need to write h all the time. Okay, so negative 16 is coming out. 16 divided by negative 16 is negative 1. We're going to take half of 1 and square it. So that's a quarter. You can use decimals if you want, especially if it's an application. So we're going to add 0.25. We're going to subtract 0.25 so we don't change the equation, and then we have 180. So it's minus 16t minus a half twice. Then I'm going to multiply the 16 times the negative 0.25, so that's positive 4. And then we have t minus 0.5 twice plus 184. So what have I found out? This is my maximum height, which occurs at 184 meters. When does that occur? At time 0.5 seconds. So the x value is representing time, the y value is representing height. We have one very common question is with finding maximum area. So what we have is a fence around a rectangular field. So we've got 2 widths and 1 length for this fencing. So my perimeter would be 2 lengths plus 2 widths, and I have 500 meters to use. And I want to maximize the area. Well, area is length times width. So what I'm going to do is isolate my perimeter formula for either L or W. I think the first thing I'll do is divide by 2 just to reduce it. And then I'm going to isolate for either L or W. It doesn't really matter which. And then I can substitute that into the area formula. Because I can't solve area with 2 variables, I have to have 1 variable. So I'm going to replace L with 250 minus W. And then we'll expand, and we have a quadratic function. Once we have that, we can complete the square to find the maximum. So leading coefficient is negative 1, so we'll take that out. Half of 250 is 125, squared is plus 15625, and then we'll subtract that amount so we don't change the equation. Don't forget to multiply that by the negative 1. So area is going to be W minus 125. We're going to have 2 of those, and then we have negative 1 times negative 15625 makes that positive. So this is going to be my maximum area. I can also see that the width is 125 meters, which would make the length also 125. Oftentimes when you have a rectangular area and you want to maximize area, it's generally a square unless you are using only 3 sides or maybe have an extra fence in there. But generally, if you just have a regular rectangular area and you want to maximize, it's generally a square. But I can check my answer by multiplying the dimensions. And if I multiply 125 by 125, I get the maximum area of 15625, which confirms with my equation there. Another common question is revenue. So when you create revenue, you take a certain number of items and then you multiply it by the price of those items. That's how we figure out revenue. So how many items am I selling at what price? So in this question, we have 600 people going to a gym, and the gym membership is $50. So what is happening? The gym estimates that every $5 increment, so the cost of the gym membership is going to go up $5, they're going to lose 50 members. So originally their revenue is $30,000. So they can increase their revenue by charging more. Let's see, we're going up $5. So we could go up $5 but we're going to lose 50 members. So for example, 60 times 50 members is $30,000. If I went up $5 to $55, now I'm only going to get 550 members because I'm going to lose 5 people. So now the revenue is $30,250. So even though I put the price up and I lost 50 members, I'm still making more money. So we want to figure out how much we can put the price up and still maximize revenue. So we don't want to do it by just estimating. We're going to do it algebraically. So X is the number of times we will change the price. So we're going to expand 600 times 50, 600 times 5, 50 times negative 50, and then negative 50 times 5 is negative 250x squared. So we'll put the x squared at the front. We'll add the middle terms. It's 500. So we want to complete the square to find the maximum. So we'll factor out this coefficient of negative 250. Leave us with a negative 2. Half of 2 is 1. Squared is 1. So plus 1 will make a perfect square. Minus 1, so we don't change the equation. And then we'll leave the minus, or the 30,000 at the end here. And then if we factor this quadratic, we'd get x minus 1 twice. We're going to multiply negative 250 times negative 1, which is positive 250. So what does that tell us? That tells us that this is our maximum revenue. And x equals 1. So what does that mean? It means that we're going to change the price once. So for example, if x equals 2, we're going to change the price twice. If x equaled 3, we're going to change the price 3 times. So changing the price once is going to give us our maximum revenue. So our new price will be $50 plus 1, and we're changing it by $5. So the new price is $55, and the new number of members is 500 members. We were losing 50 members every time we change the price, so we're losing 50 members once. So now we have, sorry, was it 50 or 600? 600. So 550 members, and then we could say, well, 550 members times $55 is $30,250, which is what we got in the equation. Okay, so there's some practice questions here, just completing the square. And then on the next page, there are a couple of applications that you can try. The answer is in brackets after the question, so you can see if you got the right answer.